Today, we're going to be working with exponents and graphing exponential equations. Not new news for you guys. The main thing I want to make sure is that you know what E does. Just a recap of yesterday, probably the most important things you learned or should have learned is remember in math class, we don't leave negative exponents laying around. X to the negative 2 in math class, we're definitely going to fix that. We're going to write it as 1 over x squared. And if I have 1 over x to the negative 2, that's going to pull that negative up to the top. Oops. And it's going to become x squared. So just some reminders. If you should know your exponent rules. When you multiply, you add the exponents. When you take a power to a power, you multiply. You divide, you subtract. Anything to the 0 is 1, except 0. Anyway, so that's just kind of a recap. Remember, fractional powers, the bottom number represents a root. So if I want to take 8 to the 2/3 without a calculator, what this means is take the cube root of 8 and then square it. So the cube root looks like this of 8 would be 2, because 2 times 2 times 2 is 8. And so then I'm going to take that 2 and I'm going to square it, and I get 4. All right, so just a little recap from yesterday. So today we're going to graph exponential functions. Exponential functions, what makes them exponential functions is you have an x here, and the x is up in the exponent. You are used to seeing things like polynomials where you had x squared. Well, now we're seeing things like 2 to the x where the x is upstairs. The base has to be greater than 0. The graphs get really strange when the bases are less than 1. And b can't be 1 because 1 to anything is 1. It's not very interesting. So the things you need to know is that the base, this b is called the base and x is called the exponent. If the base is greater than 1, then the function is increasing exponentially, such as 2 to the x. If the base is between 0 and 1, it's decreasing exponentially. So if you have something like 1/2 to the x, the function is going to be decreasing for all x. So we'll take a look at these graphs and make sure we can graph them today. All right, so the parent function, I'm going to let, for example, I'm going to graph 3 to the x. When you graph these, I would like to see 2 points, basically, maybe 3. All right. So I would like to see a negative point. I'm going to do a little bit more just to make sure we're good. I'm going to let x go from negative 2 to 2. Remember, x is your independent variable. I can let it be what I want. So y is 3 to those x's. So 3 to the negative 2, remember what a negative exponent means. It means 1 over 3 squared. So it's going to be 1/9. So negative 2, 1/9, that's pretty darn close to 0. We'll go like right there. All right. And then negative 1, 3 to the negative 1 is 1/3. So you'll know that the more negative x gets, like if x were negative 3, I'd have 1 over 27, 1 over whatever comes next, 27 to 81. It's going to get smaller and smaller. So, but 3 to the 0, let's see, 3 to the negative 1 is 1/3. So we'll put that about right there. All right. 3 to the 0 is 1. So it's going to go right there. And 3 to the 1 is 3. And 3 squared is 3 times 3 is 9. So that's going to go right there. So if I kind of connect these dots, hopefully I can do this. Oh, I did such a good job. All right, I don't have a stylus, so I'm doing this with a mouse. So it's not going to be perfect. All right, so what I want you to notice, you see that this graph will never go negative. It's always positive. So what you have is a horizontal asymptote. So these graphs, exponential curves, have horizontal asymptotes at y equals 0 because the graph never goes negative. All right, so From this, we can get our domain. The domain, you'll notice x can be any real number. There's no problem with x. So x can be any real number. Oh, I suppose I should take that. Okay. And as pretty as that looks, let's do that. All right. So the range is y. So you'll notice that y is greater than 0. It doesn't equal 0. It will never get to be that asymptote. So we just write y is greater than 0. If I were using brackets, so I'd use round brackets. I'd go from 0 to infinity. Okay? And it's a horizontal asymptote, so the equation of that asymptote is y equals 0. So this is the exponential growth function. That's the characteristic, it's growth. Things that grow exponentially are bank accounts, if you wait long enough these days, and population as well. So those are examples of things that grow exponentially. You see it in a lot of science classes, and you see a lot of exponential functions. All right, so that's exponential growth. All right, now the things about exponents. If I have y equals b to the x, whatever the base is, remember this is your base and this is your variable, it'll always go through the point x is 0, y is 1. Sorry, it's a 1, 0. Because anything to the 0th power is 1. And if x is 1, okay, so if x is, 0, b to the 0 is 1. If x is 1, you get b to the 1. Well, that's b. So whatever the base is, it's going to go through that point. So this value would be b. So it's easy to get 2 points on these exponentials. So it's going to go through 0, 1, and 1b. So basically, when you graph these things, I want to see 2 points, and I want to see the horizontal asymptote. So that's basically 3 pieces of information. All right, so if the base is less than 1, so you have 1/3, this is what we call the characteristic is this is exponential decay. It's going to be going down. You need to be a little careful with this. 1/3 can be written as 3 to the negative 1. So if I take that to the x power, you get 3 to the negative x. So please be aware that this 3 to the negative x is the same as 1/3 to the x. So, but we'll stick with this. The base is less than 1, so we're going to plug some numbers in and plot them and see what we get. -2. We're going to go from -2 to 2. Okay, so 1/3 to the -2. Let's do that out here. You have to remember a negative power, to get rid of it, means to take the reciprocal. So you can rewrite this as 3/1 squared. A negative power, take the reciprocal. So it's basically 3 squared, so 3 squared is 9. All right, so 1/3 to the -1 means take the reciprocal of 1/3. You're going to get 3. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. And 1/3 squared, square the 1, square the 3, you get 1/9. So this goes from 9, see it's going down here, so it's decaying. That's why this property is decay. So we're going to plot these points. So -2, 9, -1, 3, 0, 1. See, it's going through that point 0, 1, and 1 in the base. With these, it's better to have 3, but okay. 2 is 1/9. All right. So if I connect the dots best that I can. Whoops, not that good this time. All right, there we go. All right, it's just going, it's decaying. It's going down here. There's no little wiggle, right? All right, so this is the example of exponential decay because as I read left to right, this graph is decreasing. And again, you've got this horizontal asymptote that a line that the graph won't cross. There we go, that's what I want. All right, so you're going to have this horizontal asymptote. It will not cross it. It'll get closer and closer to it, but never reach it. So this is decay. That happens when the base is less than 1. So the domain of this is just like the last one. It's all reals. Let's fix that. All right, the range is y is greater than 0. And you have a horizontal asymptote at y equals 0. Okay, so when the base is less than 1, it's decay. When it's greater than 1, it's growth. Now, you might be asking why we're doing this. Since I don't have a calculator handy with me, you could change. Remember how to do this? We did it before in your table set. You're going to change auto to ask, and you're going to plug this into y equals, right? And so in y1, I type 1 plus 1 over x to the x. And I want to see what happens to this function as x gets large. So yeah, I guess I'll do that real quick for you guys. Let me get out of that. Here's my calculator. I don't want you to worry so much about this other than to realize this is where this number is coming from. All right. So I'm just going to type this function in my calculator. Oops, I don't want that. So in parentheses, I'm going to do 1 plus 1 divided by x. And I'm raising that to the x power. So it's kind of an odd little graph. Let's take a look at it for assume 6. Looks weird, but you can see there's like an asymptote here, and I want to take a look at that asymptote. So in table set, I'm going to change it from auto to ask. And I'm going to type in some numbers and let x get really big, and we can see if we can figure out what it's going to. So let's do 1, 5. I skipped 2, that's fine. 10, 100, 1,000, 2.716710000, 10,000. It's 2.7181. Let's do 100,000. 2.7183. And you can pretty much tell it's going to this number, 2.718. It goes on forever. This number is an irrational number. There's a guy named Euler who discovered this number. He found out it was going to this asymptote, but he didn't know why, but they call it E. And we'll see later the applications that he has in logs, because it's called the natural base logarithm. So as n goes to infinity, this number is going to 2.718 dot dot dot. We don't need to know much more than that. It repeats infinitely like pi. It's irrational. So they called this number, the guy that invented it, his name was Euler, E-U-L-E-R. Or the guy that found it, I should say. And so they named the number after him. So they call this number, this constant E. So E is just a number, just like pi. And E is very useful when you get to calculus and when you get to upper math. It's just an easier way to write growth and deal with logs, as we'll see when we get to logs. So the number E is an irrational number defined as the number, the quantity 1 over 1 plus n to the n. But what happens is n gets really large. So that's how they define E. That's how I found it. It's just a number. It's 2.718. E occurs so often in applications, it's referred to as the exponential function. So in science, when they talk about exponential functions, they're generally talking about E. So E, you need to know. You just need to memorize this 2.718. All right. And it's probably come up in your science classes already. All right, so e to the x, it's exponential growth because this number is bigger than 1. So I'm just going to do a few numbers, -1, 0, 1. That's probably good enough. E to the -1 is 1 over 2.718. So that's about a third, right? Roughly. You're not going to be able to graph this very well. So -1 is about a third. E to the 0, well, e to anything to the 0 is 1. 2.7 to the 0 is 1. And e to the 1 is 2.718. You're not going to be able to graph it that well, so we'll just stick with 2.7. And that's probably pretty good. You can see your exponential growth here. If I connect the curves, so it's going to have a particular growth pattern with a base of 2.718. So it's somewhere between 2 to the x and 3 to the x. Let me finish this out on here. So remember, you have your horizontal asymptote. So e to the x has a horizontal, oops, it doesn't go up. It's 0 that it's not going to reach. And let's draw the horizontal asymptote. Okay, so it is basically just an exponential growth function, but it's one that is significant. All right, so the domain is all reals. The range is, of course, y is greater than 0. It has the asymptote at y equals 0. And characteristic, it is growth because 2.718 is a number bigger than 1. So it's growth. Okay. All right, so we're going to take these basic curves and just do some transformations. So remember, if it's on the inside, if it's next to x, it's an x transformation. If it's on the outside, it's a y transformation. X does the opposite of what you think it should do, and y does what it says. So if you look at this, it says 3 to the x minus 2, so this is a shift 2 to the right. So it does kind of help to do a table and put the asymptotes on there as well. So I'm going to draw the parent function of 3 to the x. Let's see, I'm just going to do 3 points. I like -1, 0, and 1. You can do as many as you need to get that graph in there. First of all, I like to graph the horizontal. If I shift the graph to the right, it's not going to change the horizontal asymptote because you're going right and left. So I'm just going to put that on there because we already know where it is. It's here at 0. Okay. So 3 to the -1 is 1/3. Whoops, that's not going to work. 3 to the 0 is 3 to 1/3, sorry. 3 to the 0 is 1, and 3 to the 1 is 3. So remember, this shift -2 means I'm going to the right 2. So I'm going to take all my x's and add 2 to my x's. I would suggest using tables for these because they're somewhat more difficult to see just by looking at the graph. So if I add 2 to all my x's, this -1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3, and these guys stay the same. So y stay the same, 1/3, 1, and 3. So I'm going to graph these points. Here are my 3 points. All right, so 1 is 1/3, 2 is 1, and 3 is 1, 2, 3. Okay, and then I'm just going to, remember, it's going to head toward that asymptote, and go up and go down forever. Okay, so all this is adding to your abilities to do transformations. All right, so this one here, the parent function is 1/3 to the x. So we graphed that earlier. Again, 3 points I would like to see in an asymptote. All right, so now 1/3 to the -1. I'm going to do the parent function, 0, 1. 1/3 to the 1 is 1/3. 1/3 to the 0 is 1. 1/3 to the -1 is 3. So the transformation that you're doing is down 4. So I'm going to subtract 4 from all the y's. So -1, the x's stay the same. 3 minus 4 is -1. 1 minus 4 is -3. 3. And 1/3 minus 4 is negative 3 2/3. Can you see that that's approaching negative 4? What I would suggest is putting the asymptote on there first. So I'm going down 4. So that's going to shift the horizontal asymptote down 4. So 1, 2, 3, 4. So the horizontal asymptote is now at negative 4. And then I can plot my points on there. And so negative 1 is negative 1. Oops. Negative 1 is negative 1. 0 is negative 3. And this is exponential decay, so it should be going down. And negative 1 is negative 3 2/3. So you see how we're approaching negative 4, but not quite getting there. So there we have it. Right, on this side, it's going down, so on this side, it's going to go up. I want to see on these graphs 3 points in an asymptote. So this is y minus 4, I guess I should put there. Okay. All right, so that's me messing up, and let's go here. All right. You can graph e to the x as well. It's just that you have to remember that e to the 1, the way that I remember is 2.718. So when I graph that, I'm going to make a little parent function here. So, you know, you don't have to be perfect with this. When x is negative 1, e to the negative 1 is 1 over 2.7. So I'm thinking it's like a third, roughly. I mean, it's not perfect, but it's just a graph. E to the 0 is 1. And e to the 1 is 2.718. 2.7 is fine here because we're just graphing. All right. So the transformations that we're doing in this graph, the exponent is with x, so minus 4 means 4 to the right, and up 1, plus 1 means up 1. So if I'm going 4 to the right, I'm going to add 4 to x. Remember, we do the opposite for x. And to my y's, I'm going to add 1. Okay? Before I do that, let's take care of the asymptote. So the horizontal shift doesn't affect the asymptote, the vertical does. Because we're going up 1, the asymptote is going to shift up 1. So let's put the asymptote on there. It's just really helpful to get that asymptote on there so you can kind of see it. Now, this should be an exponential growth curve. I haven't flipped it or transformed it, so in that way, so that's what I should see. I'm going to add 4 to all the x's, so negative 1 plus 4 is 3. Let's put on a regular pen. 3. 0 plus 4 is 4, and 1 plus 4 is 5. And I'm going to add 1 to the y's. So 1/3 plus 1, think of it that way. 1/3 plus 1 would be about 4/3 or 1 1/3. I'll write it that way, roughly. 4 plus 1 is 5, and 5 plus 1 is 6. So let's plot these points. So 3 is 1 1/3. See, that's where it's approaching that asymptote. 4 is 5. Okay. And 5, oh no, yeah, and 5 is 6. What am I doing? You know, oh, I did it wrong. Okay, forget that. Y plus 1. 1 plus 1 is 2. And 2.7 plus 1 is 3.7. Sorry, I was reading the wrong numbers. Okay, so 4 is actually 2. That makes a lot more sense. And 5 is 3.7. Okay, so again, there's your exponential growth. I want to see the 3 points. You're going to head down to the horizontal, and right, just go smoothly down. I can't draw it that well here. The domain is all reals. The range in this case, y is greater than 1. And the equation of the asymptote is y equals 1. Okay? All right, so this next one, e to the negative x plus 1. Let's talk transformation. I've got the parent right here, so I'm not going to redo that. So I'm multiplying x by negative 1. So I'm going to change the sign of the x's. And I'm going to add 1 to y. Now you need to be careful with this because think about if I replace x with negative x. Think about it, x with negative x. I'm flipping over the y-axis. So that's what I should see is growth flipped over the y-axis turns into decay. But okay, so we're going to change the sign of the x's. 0, no, not 0. What is this one? 1, 0, and negative 1. I'm changing these signs, and I'm going to add 1 to the y's. So 1 plus a third is about 1 1/3. 1 plus 1, you know. And then 1 plus 1 is 2. And 1 plus 2.7 is 3.7. All right, again, I like to get the asymptote on there first. The negative isn't going to do anything, but the up 1 is what changes the asymptote. So the asymptote is going up 1. Okay, and let me plot my points. I'll plot this in red. All right, so 1 is 1 1/3. 0 is 2. And negative 1 is 3.7. So you can see that decay starting to kick in here, right? It's going down now. Oops, doesn't really cross the asymptote. Just can't draw it real well on my computer. All right, so the domain is all reals. The range is y is greater than 1. And the asymptote is y equals 1. So you can see that that negative here took this curve and flipped it over the axis, right? Over the y-axis, and it went up 1. All right, so you can see that effect on your graph. All right, so that's e to the x, and that's it for today. Practice with your transformations. Remember, you can check these graphs. You shouldn't do them on a calculator, but you can check them on a calculator. There is an E button on your calculator if you weren't aware of it. Just to show that to you real quick. See, there's ln here, which is natural log, and there's your natural E. It's in blue. So if I wanted to graph e to the x on my calculator, I'd hit second e to the x, and it comes up e to the box, and you type that x, and you can graph it. And you'll see that exponential growth curve. So you can check any of these graphs on a calculator. I would suggest doing it without a calculator and using a calculator to check. I will see you guys on Monday. Have a good weekend. Thanks.